All righty. So this is what your homework was on, fellas. Your homework was on the law of sines. All right. Now, if you guys have any questions at any time, just actually say, hey, coach, I got a question, right? So here's what the law of sines says. In a triangle, there are relationships that are always true, right? So you know when you have a triangle, you just use 3 capital letters, right? You use capital letters for the angles, and the sides opposite those angles are used with the lowercase letters. So if we use A, B, and C for the angles, lowercase a, lowercase b, lowercase c. But if I used R, S, and T, it would be R, S, T. Does that make sense? You guys understand that, right?
Yes, sir.
Not all triangles are A, B, C. All right, now, here's what we know for a fact. If we have a triangle, these ratios are always equal. The sine of angle A over side A has to be equal to the sine of angle B over side B, has to be equal to the sine of angle C over side C. Every triangle ever drawn, all right, I got a couple guys trying to get in, right? Hold on one second. Every triangle.
There you go.
Huh? All right. Is that Cedric? Cedric, you in?
Yes, sir.
Sawyer, you in?
Yes, sir.
No, it's not me. It's not me.
All right. So here's what we're doing. Every triangle drawn, those ratios are always equal. Does everybody understand that?
Yes, sir.
All right. It's important to know that, fellas, because we can't use the Pythagorean theorem for everything. All right. All right. So we can't use the Pythagorean theorem for everything. So the first thing I want to do is you got your homework in front of you probably? Yes? No, maybe? You got that worksheet in front of you, right? Hello?
Yes.
Let's look at number 2. All right? If we look at number 2, let me just draw it for you here. If you look at number 2, it looks something like this, right? Is this what it looks like? Yep. All right. Hello. What did I tell you?
Yes.
17 degrees, right? What else did I tell you? This is 46 degrees. And then this is, what is it, 18? All right. Now, what did I want you to find? All right. Now,
Find X.
Yeah, they want you to find. How come I can't use the Pythagorean theorem?
It's not a right triangle.
Very good. It's not a right triangle. If it's not a right triangle, you can't use the Pythagorean theorem, all right? So, what am I going to do? Well, it's a triangle. So what do I know? These ratios have to be true. So whenever you have 2 pieces of information, when you have an angle measure and the side opposite, when you have an angle measure and the side opposite, you can use the law of sines. So look what I have. Hey, fellas, anytime you know 2 angles of a triangle, how many angles do you know? Anytime you know 2 angles of a triangle, don't you know the third?
Yeah.
Yeah, why?
Because they add up to 180.
Because all the angles of a triangle have to add up to 180. So 46 and 17 is 63 degrees, right? Yes? So
Yes.
then if I go 180 minus 63, what do I get? 117, right? So this angle is 117. Now, that's going to help us find X. So what do I know has to be true? Look what I have. I have an angle and the side opposite. So the sine of A over A becomes the sine of 46 over 18. Now, Jacob Moore, trying to get in. All right. What's that going to be equal to? Well, I want to find this side. What angle do I use? C or B? Hey, come on. If I'm trying to find this side, what angle am I going to use?
C.
Yeah, the side opposite. So the sine of 117 over x. So that's how you set up. Does everybody see how you set that up? Come on, guys, you got to talk to me. I can't see.
Yes, sir.
All righty. Now, how do you solve an equation between two fractions? What do you do? Yeah, cross multiply, ready? So this is x times the sine of 46 has to be equal to what? 18 times the sine of 117. Did you guys do that properly?
Yes, sir.
All righty. Now, we want x by itself. What are you going to do? We want x by
Divide by sine of,
Very good. And whatever you do to one side, you do to the other, right? Over here, I'm left with x. And over here, I'm left with 18 times the sine of 117 over the sine of 46. Now, fellas, that's just a number. Here's what you don't do. Don't change these to numbers and then do the division. Take out your calculator, do 18 times the sine of 117, close the parentheses, and divide it by the sine of 46, and close the parentheses. And then somebody tell me what you get. What did you get?
22.3.
Very good. 22.3. Does that make sense to you guys? Yes?
Yes, sir.
What if I asked you to find this side? What would you do? The sine of 46 over 18 equals what? Sine of 17 over that side. You can do that yourself if you want. Is that understood? You want to do another one of those? Hello? Let's do another one of those. We got to make sure we know how to do this. Let's look at number 3. Look at number 3 in your homework, right? We got a problem that looks like this, right? A, B, C. And here's what they tell you. They want you to find this side. This is 38, right? And we got 51 and 86. All righty. Now we don't even have to do too much work. Can I use the law of sines here? Well, obviously, it's a homework problem on the law of sines. Can I use the no?
yes,
Yeah, because I have a what? I have an angle and the side opposite. So what am I going to write? The sine of 51 over 38 equals what? The sine of 86 over x. Does that make sense to you guys? Do you see how you always use the angle and the side opposite? Does everybody understand that? Yes or no?
Yes.
All righty. So now all we got to do is what? X times the sine of 51 equals 38 times the sine of 86. How do you get x by itself? How do you get x by itself?
divide by sine of 51.
Yeah, just divide both sides. If I divide this side by the sine of 51, I have to divide this side by the sine of 51, and I get x equals. Now, if you take out your calculator, don't change any of those numbers yet. 38 times the sine of 86, close the parentheses, divided by the sine of 51. What do you get with that? 38 times the sine of 86 divided by the sine of 51. What do you get with that?
48.88.
Beautiful. Does that make sense? Now, fellas,
Yes, sir.
sometimes we have to use the law of sines because we're not dealing with right triangles. The law of sines work with right triangles, but we don't usually have to use it for the right triangles because we don't need to do all that work. Right? We have other ways of doing it. Does that make sense? Yes or no? All right.
Yes.
That was your homework, so hopefully you put that in. All right, page 107, numbers 2 through 4. Right? Does that make sense to you guys? All righty. So we'll come back to that around on Thursday when we're finishing up our review for your exam. Right? Right? You'll have your exam this afternoon. You can print that out, and then you can see what's on it, and then any questions you might have, you'll be free to ask them to me on Thursday, right? So, but now we want to get into, let's go back to the start of the chapter, all right? And the first thing you talked about in this chapter was the Pythagorean theorem, right? And what's the Pythagorean theorem talk about? What's the Pythagorean theorem talk about, fellas?
A squared plus B squared equals C squared.
It talks about the relationship between the legs and the hypotenuse in a right triangle, all right? So if you have a right triangle, right, the side opposite the 90-degree angle is called the hypotenuse, right? And we use C for that, right? What do you call these two things? What do you call side A and side B?
The legs.
Yeah, the legs. And fellas, it doesn't matter which one is A and which one is B. The only thing that matters is you know what side is the hypotenuse. And here's what we know about every right triangle. If you have a right triangle, this relationship is always true. The hypotenuse squared is equal to the sum of the squares of the two legs. And that's what we mean by C squared equals A squared plus B squared. Does that make sense? So one of the things we're going to ask you to see if you can do is we're going to give you like 3 numbers, and we're going to sit there and go, are these the sides of a right triangle? So for example, if I said to you, I'll give you a nice easy one, 3, 4, 5. And if I said to you, can 3, 4, and 5 be the sides of a right triangle? How would you tell me whether or not they could be the sides of a right triangle? Well, if they are, what has to be true? If they are, what has to be true?
Pythagorean.
Yeah, it has to work. So I go C squared equals A squared plus B squared. Now, the only thing you got to make sure of, which one is C? C is
The biggest one.
yeah, C is the hypotenuse, so it has to be the longest side. So 5 squared, does that equal, now A and B, it doesn't matter which one is which. 3 squared plus 4 squared. So if this works out, what do we have? We have a right triangle. What's 5 squared? 25, right?
25.
What's 3 squared? 9. What's
9.
16.
16.
What's 9 plus 16?
25.
Is 25 equal to 25, fellas?
Yes.
Yeah, of course it is. So these 3 numbers, when you put them into the Pythagorean theorem, work. And if it works, it means you have a right triangle. Does that make sense? Does that make sense, fellas?
Yes.
Yes,
All
sir.
right. Let's try another one. Let's try, instead of 3, 4, and 5, let's try 6, 9, and 11. Let's try 6, 9, and 11. If I said to you, are those the sides of a right triangle? If they are the sides of a right triangle, what would have to be true? If those were the sides of a right triangle, what would have to be true? They would have to work, right?
Yeah.
All righty. Which of those three sides has to be C?
11.
11.
11. So I'm going to substitute 11 squared. Now, it doesn't matter which one's A and B with the other two. 6 squared plus 9 squared. Right? What's 11 squared? What's 11 squared?
21.
Yep. What's 6 squared?
36.
What's 9 squared?
81.
Good. So, on the left side, I got 121. On the right side, I don't got 121. What do I got?
So, yeah.
I got 117, right?
Mm-hmm.
Yes? All right. So here's what we know. 121 is not equal to 117. So what don't I have?
Right triangle.
I don't have a right triangle, but I do have what? I have a triangle that's either obtuse or acute. So if I go back to my problem over here, what's the symbol that goes in here? Is that the correct symbol? Is that the correct symbol that goes in there? Hello?
Yeah.
All righty. So here's what I know. They're not equal, so it's not right. But it is going to be obtuse or acute. All right? If the hypotenuse squared is greater, then it's obtuse. Right? If the hypotenuse squared is less than, then it's acute. Now, the way I remember that, and hopefully you can remember it this way, the way I remember it, what does obtuse mean? Greater than 90, right? So when I see greater than, I just go obtuse. Does that make sense to you guys?
Yes.
All right.
Yep.
So that's the first thing that you guys learned how to do. The first thing you guys learned how to do is you learned how to take the Pythagorean theorem and use it to determine whether or not the triangle was right, obtuse, or acute. Does that make sense? So that's the first thing you're going to be asked to do on your test, right? Does that make sense? All right. The next thing that Mr. Vombalski talked about was what? Special right triangles. Right? Special right triangle. He gave you two. What were they? 45, 45, 90. What was the second one?
30, 60, 90.
60, 90. All right? Now, here's what you got to remember. There's still right triangle. There's still right triangle, fellas. So what else do you know works? The Pythagorean theorem. But there's a couple of things that we can learn or use that might make our work a little easier, right? So let's take the first one, 45, 45, 90. So it looks something like this, right? Who knows the fancy word for Who knows the fancy word for 45? The fancy word for 45. Somebody turned on your audio. What's the fancy word? Isosceles. What's isosceles mean? What's an isosceles triangle? Two legs are congruent, right? How do I know these two legs have to be congruent? How do I know these two legs have to be congruent?
The two angles are the same.
Two angles opposite them are congruent. Very good. So the fancy word for 45, 45, 90, isosceles. Now, there's a relationship. Ready? Let's use a number. What else do I know? What else do I know, fellas? Right out of the gate. What else do I know? If this leg is 5, what's that leg?
5.
Yeah. Right? That's the first thing you know. Hey, what's this? Who remembers the rule? Let's say you didn't remember the rule. What could you use? What could you use? It's a right triangle. What could you use? What's that? What's that?
Pythagorean theorem.
Yeah, so if I do that, c squared equals 25 plus 25. C squared equals 50. So c is the square root of 50. And if I reduce that, I get 5 radical 2. Now, I didn't have to do all that work because when I have a 45, 45, 90 right triangle, I know the hypotenuse is radical 2 times the side. Does that make sense? It's just a way to make your life easier. So that's the first thing you got to remember. The hypotenuse in an isosceles right triangle is radical 2 times the side. So for example, if I tell you this is 7, what are the other 2 sides? Go.
7. 7 radical 2.
Yep, you don't have to do any thinking. All right? Now, what if I give you that? What would you do?
7.
Divide by radical 2. What are you left with?
7.
7. I'll give you a little harder one. What if this is 30? How do you get rid of that? What's this? If this is 30. Well, what did I do when it was 7 radical 2? What did I do when it was 7 radical 2? Didn't I do that? I know. All right, so what do?
Divide by 1.
And now you just rationalize that, right? Right? So 30 radical 2. Hey, fellas, what's the square root of 2 times the square root of 2? Square root of 4, what's that? 2. So what's this? 30 divided by 2. 15 radical 2. Make sense? That's a little more complicated, but not impossible. So that's the first thing you want to remember. When you have a 45-45 right triangle, right? Isosceles right triangle, the hypotenuse is always radical 2 times the length. Now, second one, 30, 60, 90. Now this one isn't so easy, but there's rules that make our life really easy. Ready? So it looks something like this. So this is going to be A, B, C. This is going to be 30. So if I know this is 30, this has to be what?
30.
60.
Oh, shoot.
30 and 90 is 120 and 60, right? So if one of them is 30, the other one's 60. If one's 60, the other one's... Now, here's what I know. If I know this is 3, right? So now what do I know? I know the side opposite the 30 degree. How do I know this is the smallest side? How do I know that's the smallest side?
It's across from the smallest angle.
Because it's opposite the smallest angle. Ready? Now, what's the hypotenuse? Who remembers the rule? How come I know that's 6? What's the rule? Somebody tell me the rule. Hello? What's the rule? What did I do to the shortest side? Come on. I multiplied it by?
Square root of 2.
I multiplied it by 2, not the square root. That's in parentheses. So when you know the shortest side in a 30, 60, 90, the hypotenuse is simply 2 times. Got it? What about this one? What's the rule?
Times the square root of 3.
Very good. Times radical 3. So here's what you know in a 30, 60, 90. In a 30, 60, 90 triangle, the hypotenuse is 2 times the shortest side. The longer leg is radical 3 times the shortest side. Does that make sense? So if I give you one of those, you should be able to give me the other. Now, if I knew this and this, I could figure that out using the Pythagorean theorem. But why would I do that when I could do it all in my head? Does that make sense? Does that make sense to you guys? Let's see if I can give you an example. Ready? Let's try to do this one. Let's see if we can do this one. All righty, here we go. I'm going to draw a 30, 60, 90 triangle. Ready? All right. This is A, B, C. And here's what I'm going to tell you. This is 10. All right, everybody see that? Now, what side did I give you?
Hypotenuse.
This is 60, right? So this has to be 30, right? All right, now pay attention. I could use a trig ratio to figure out the 2 sides, but I don't want to do that, right? Because I know what? 30, 60, 90. What side do I know? The hypotenuse, right? So what did I say was the hypotenuse? 2 times what?
The shortest.
The shortest side. So which is the shortest side? A or B? Which one's opposite the smallest angle? Is it A or B?
Is it from 30?
Yes, A. Well, I know this is 2 times this. So what's this? If 10 is 2 times this number,
5.
5. Wait, what do you know about the longer side? The longer leg. It's the shortest side times radical 3.
Square root of 3.
So what is it going to be?
Divided by the
5
square root of 3.
5 radical 3.
radical 3. There you go. Now, what does that help you do? That saves you a lot of time and a lot of work. Because if I didn't know that, if I didn't know those rules, I'd be using trig ratios. Now, guess what you'd still get? You'd still get the right answer. It would just take you a lot longer to do it. Does that make sense? Yes, no, maybe?
Yes.
All righty. Hey, fellas, like, you have to be able to ask me questions if you don't understand what I'm doing, all right? Does that make sense? So those are the first 2 things we're going to talk about on your exam. First 2 things you're going to see on your test, all right? You're going to see the Pythagorean theorem, the use of the Pythagorean theorem, and you're going to see the use of, like the rules for 45, 45, 90, and 30, 60, 90 right triangle. All right? Does that make sense? Now,
Yes.
what do we use the Pythagorean theorem for? To find angles or sides.
Sides.
Sides. Now, when can we use the Pythagorean theorem? When we know. What do we need to know in order to use it?
Right triangle.
We need to know we have a right triangle, but we need to know 2 of the sides, don't we? Yes?
Yes.
All right. What if we don't know 2 of the sides? Let's say we only know 1. Let's say we only know 1 of the sides and we know some other information. Well, we know 2 sides. So if we're going to talk about trig ratios, what's a ratio? What's a ratio? Give me another word for ratio. 4th grade word for ratio. Fraction? Hello?
Yeah, that's right. Fraction.
Fraction. All right, so here we go. You guys ever see this before? What's that?
Sine, cosine, tangent.
Yeah, that's SOHCAHTOA, right? Yes? Sine, cosine, tangent. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. All right? So I learned that in like 1977, 76, right? So what that means is angles have sines, cosines, and tangents, not sides, angles. So when I have a right triangle, right? When I have a right triangle, let's say I draw you a triangle that looks like this. Right? Can you guys see that? You guys can see that, right?
Yeah.
All right, so here's what they give me, right? And here's what I know about this triangle. This is 73 degrees, and this is 6, right? What if I said to you, tell me that side? How come you can't use the Pythagorean theorem?
You only know one side.
Because you only know one side. If I wanted to use the Pythagorean theorem, I have to know 2 sides. Now, based on what I have, which of these 3 trig ratios would I use? Well, what's the number I know? What's the number I know? 6 is what? A, B, or C?
C.
So that's the hypotenuse, right? It's opposite than, so I know the hypotenuse. Now, if I use 73 degrees, is this side opposite or adjacent?
Adjacent.
It's adjacent. What's adjacent mean? Next to. What can the hypotenuse never be? Adjacent, right? So next to. Adjacent means next to. Belliver sits adjacent to Smith. You know what I mean? So what I do, I'm going to use the adjacent over the hypotenuse. That's the cosine. So the cosine of 73 degrees has to be equal to x over 6. Does that make sense to you guys? Do you see how we did that? Did we see how we did that? Hello?
Yes, sir. Yes, sir.
Yes, sir.
How do you solve that? What's x times 1?
1x.
Yep. What's this? 6 times the cosine of 73 degrees. Hey, take out your calculator. 6 times the cosine of 73 degrees. What do you got? Make sure you close the parentheses.
1.75.
Beautiful, 1.75. Very good. Does that make sense, fellas? Now, so this is 1.75. What if I asked you for this? What could you use? What's this?
Opposite.
Over?
Hypotenuse.
Yeah, I just use the opposite over the hypotenuse. Why wouldn't I use the opposite over the adjacent? What would make this one easier to use than this one? Let's say you didn't have a calculator. What's the easier part about that number? No decimal, right? Well, let's just set it up. Ready? So we're going to use what? The sine of 73 equals a over 6. Right? the sine of 73 equals a over 6. How do you solve that? Equation between two fractions. What's that? What's that? Take out your calculator, fellas. 6 times the sine of 73. What do you get?
5.7.
5.74. Very good. Now let's see if that makes sense. Let's see if we can do like a quick, like if you were on a test, you just want to make sure that you think you might be right, right? All right. So this is 90. This is 73. So this is what? 17, right? Why does that have to be 17? Because the three angles have to add up to
180.
180. Good. So, is the hypotenuse still the longest?
Yes.
Yeah. Is this number the shortest side opposite the smallest angle?
Yes.
Yeah, so I'd be pretty confident that I did that right. Does that make sense to you guys? Does that make sense to you guys?
Sir.
All right, I think we got time for one more of these. Let's see if we can do this properly. I'm going to give you a picture, and we're going to try to find the missing pieces. You tell me, right, what you think, right? So here's your diagram. All right, and they tell you the angle A is 15 degrees, and then they tell you that side A is 16. If I said to you, can you guys see that? If I said to you, what's C? Well, how come you can't use the Pythagorean theorem?
Because you only know one side.
Yeah, because we only know one side, but I do know enough to use a trig ratio. So based on what they give me, what trig ratio am I going to use to find C? What did they give me? This is the what?
The hypotenuse.
Yeah, and that's never in the numerator. Is this opposite or adjacent?
Opposite.
All right, so what's opposite over the hypotenuse? You should have SOHCAHTOA written. Which one's opposite?
Cosine.
What's that? Opposite over the hypotenuse. What is that? What letter is that, Hunter?
S.
So is it going to be the cosine?
No, sir.
It's going to be the...
Sine.
Sine.
Hey, fellas, when you take your test, just write down, you're going to be able to use your notes and everything. Just write SOHCAHTOA. So here's what I know. The sine of 15 degrees equals what? What's the opposite side?
16.
What's the hypotenuse?
C.
All right, solve it. What's 1 times anything? What's 1 times anything?
The thing you
Oh,
multiplied,
right.
I think, yeah.
And then C times the sine of 15. Hey, fellas, what would you do to get C all by itself?
Divide by.
No, this
Good.
is
You divide it by the sine of 15. And whatever you do to one side, you do to the other. All righty, take out your calculator. 16 divided by the sine of 15 gives me what?
61.81.
Beautiful. I go 61.82. Very good. 61.82. That's not a big deal, right? All righty. Let's find B. All right. I got 15. I got the angle 15. What ratio am I going to use? Look, ready, watch. Bing, bing. What's that? What's that? It's either opposite, adjacent, or hypotenuse. What is that?
Opposite.
And what's this?
Adjacent.
What's opposite over adjacent? SOHCAHTOA,
Tangent.
the tangent. Very good. So here's what I know. The tangent of 15 has to be equal to 16 over B. Now, there is a different way I could have done that, right? I could have figured out that angle right there and then use the opposite over the, but I wouldn't do that. That's no big deal. Ready? Go ahead. What do we do? What's 1 times anything?
The number. Yeah.
Itself, right? B times the tangent of 15. Hey, fellas, how do you get B by itself? How do you get B by itself?
Divide by tangent.
And whatever you do to one side, hey, fellas, anytime you're doing algebra, what's the big rule you remember? Whatever you do to one side, do to the other. All righty. So you take out your calculator. You do 16 divided by the tangent of 15. And what do you get?
59.71.
Beautiful. All righty. Now let's see if this makes somewhat type of sense. All righty. So this is 16. This is 59.7. And that's 61 point. Is the hypotenuse the longest side?
Yes.
Yes. Is the smallest side opposite the smallest angle?
Yes.
Yeah. So I'm pretty confident we did that right. All right. You know why? Because we did do it right. Does that make sense?
Yes, sir.
All righty. So we still got a ways to go, all right, in terms of making sure we're ready for our test. Not too much more, but here's what you're going to do for your homework, fellas. Here's what you're going to do for your homework. After my class this afternoon, I'm going to upload a copy of the Chapter 8 test, all right? And then you're going to print it off and have it in front of you when we take class on Thursday. Now, you can start working on it as soon as you have it. Does that make sense? All righty? You can start working on it as soon as we have it, right? And on Thursday, I'll finish up my review, and then you can ask any questions you want to ask. Does that make sense?
Yes.
Anybody have any questions right now?
No, sir.
All righty. Does everybody understand what they got to do for homework? It's not a big homework assignment.
Yes, sir.
Yes, sir.
You can handle it? Hey, just make sure, just keep plugging away. This is a total pain in the butt, but this is going to be over sooner rather than later, right? And then we just get back to living the way we normally do. This is a good opportunity, though, for you to understand all the things that are important. Is that understood?
Yes, sir.
All right, so make sure you have a good lunch. You got 2 classes this afternoon, probably, right? Yes?
Yes, sir.
Yeah.
All righty. So make sure you download a copy, right? Print out a copy and bring it to the class. If you look at it beforehand, you can start working on it as soon as you get it. All right? Does that make
All right.
sense?
Mhm.
All right. All righty. You guys have a good day. All right.
You
Yes,
too.
sir.
All the best.
Wait, sir, are you emailing it to us?
Yeah, it'll be in Blackboard.
Oh, okay.
All righty.
Yes,
Not
sir.
till this afternoon, though.
Okay.
All right. Good.